Okay, I missed part D on that last one, so on the last video, so we're going to finish with that. So on part D here, we have to complete the memory diagram, the 5 blanks that are bolded, when the program is finished executing. So after the entire thing has been done, but not exited yet, right? So the memory is still there. Assume no padding and ensure values are in hexadecimal, right? So usually we're going to convert things to hexadecimal here. So first we're looking for what is the value of P. And so this is one of the reasons I recommend doing this method, is it shows that we got to P equals 4, and that's what caused us to exit our loops. It's a common mistake that people will like kind of look at this condition and say, oh, it has to be less than 3 or less than 4, so it must be 3. But we do update it to 4 before it exits the loop. So if we look at that variable, it's going to be 4. And you can see here, this is in little endian order. And so we know that we have that OX04 at the top of P on the little end of that number. And that's how we're going to store it in memory. Moving on to the next blank, we've got announcer at 0 to fill in. And we can see that these are sort of all in ASCII for the character there. So we'll actually need our ASCII table for this. We can kind of match it up with what's in announcer here. So we've got IT apostrophe S blank, the bottom of the 9th, so on and so forth. So we can represent that this is IT parenthesis or quotation mark S, right? And that's what we're going to see there in the ASCII table. That's what we're going to find in memory. So let's grab that ASCII table here and see what we've got. We're looking for capital I in the ASCII table, and we find it here. And so you'll be given this on the exam. Just make sure you know how to use it. Find capital I, and that is OX49. We're going to enter into memory there. So again, that's just using the ASCII table, making sure you can find a character. Moving down, we've got this blank on the left here, and that's looking for an address, right? So we see that it's BFFF70F. And really, this one's just asking us to count in hex. So when we add 1 to F, that gets us to 16, right? Which is our tens in hex, right? So we don't have a digit for 16. That means we're going to carry the 1 to the next position. And so this is going to be OXBFFFF710 is our updated value there. And so we can see we just basically added 1 to this number to get to the next address. Moving on, we've got 2 at the end of umpire. And so here we might use that ASCII table again. But we can also just kind of look at the code and see like, okay, umpire in the code is strike, right? And so that's what we're going to have listed here. I'm going to try to just spread this out a little better so we can see both at the same time. So we have STRIKE, and then we wonder, okay, what's at the end of this? And that's, we talked about before, that null that goes in memory here. So we're going to have OX00 and then another OX00. So it just initializes the remainder of that string with the null and then zeros after it. So more nulls. That's it for that problem, finally.